Alright, happy snow day. Here are the notes about static electricity that we were going to do today in class anyway. Just follow along my notes and fill in your handout that you picked up yesterday, and then we will discuss when we return to school and start our lab stations for static. So before we actually get into static electricity, we need to do a little bit of review. So remember back in first semester, we started talking about atoms in chemistry. So remember those tiny little particles that make up all matter. These are what are called atoms. Usually atoms have an equal number of negative and positive particles to make them neutral. So usually they have maybe 2 plus and minus 2. That would be 0. It'd be neutral. It'd cancel each other out. So just to review, the 3 particles that we're talking about are neutrons, protons, and electrons. So remember, neutrons live here in the nucleus, and they don't have any charge at all. They're neutral, so they have a 0 charge. The positive ones are called protons. They also live in the nucleus, but they are positive. Remember the perky patty proton? They're positive. The other ones live out here. These are called the electrons, and they are negatively charged. So these are the only ones that are going to move around. So when we start talking about the transfer of charge, the electrons are the ones that move from one object to the other. Protons and neutrons do not move at all. So just like magnets, we have things that attract and things that repel. So these are called the law of electric charges. Charges that are the same, like 2 protons or 2 electrons, they repel each other. They're the same, they don't want to be near each other, so they go away. Charges that are opposite, like a proton and an electron, a plus and a minus, they attract each other. Opposites attract. So plus plus repel, minus minus repel, plus minus attract. This interaction is called electricity. This is where we get it. It's from the moving of electrons is where we get this electric charge from. So remember when we talk about forces, force just means a push or a pull. This is exactly like magnetic force. The only difference here is I'm now changing the word magnet from poles to charge. So this push and pull between these electric charges is the electric force. Exact same reasoning as the magnetic force. The difference here is the magnetic or the electric force depends on 2 different things. It depends on the amount of charge and the distance between the charges. When I say the amount of charge, I mean how much electrons it has on the object. So if you, let's say we take a balloon and you rub this balloon on your head and then your hair sticks to it. Well, if you rub the balloon on your head a lot longer, you're going to get more charge in the balloon and more hair is going to stick to the balloon. So the greater the charge, the greater your force is going to be, the more static you'll have. The distance between the charges is how close it is. So if you charge that balloon and you hold it really, really far away from your hair, it's probably not going to attract any of the hair. That's because it's too far away to have that attraction force. But if it's close to your hair, that's why your hair sticks to it, because the closeness of the balloon to your hair increases the force. So the distance and the amount of charge both increase your force as you go either toward it or away from it, or if you have a greater force or lesser force. The electric field is also the same as the magnetic field. The field is just the region around the charged object where the force can either pull or push into that field. So just like magnets, we use field lines. So just like you drew with your magnets, if you have opposite charges, they're going to attract. So their field lines are going to connect to each other because they're attracted to each other. If they're the same, like 2 pluses, they're going to repel each other. So the field lines go away from each other. So far, this is exactly the same as what we've already talked about with magnetic force and field. We're just using electric charges instead of poles. Okay, now that we've gone over that, we can finally get into the principle of static electricity. So the word static means stuck or not changing. So when extra electrons are collected and they stay on the object for a long time, that's what we call static electricity. Electricity that does not move. It stays stuck. So there's two types of static charges that we can talk about. If an object loses electrons, it has an overall positive charge. If an object gains electrons, it has an overall negative charge. Once you have two objects that has a positive charge and a negative charge, that's when they stick to each other, kind of like this guy with balloons on his head. The balloon has an overall negative charge. The guy's head has an overall positive charge. Because what happens when you rub the balloon on your head, you're stealing electrons from your head. So the head is losing electrons, making it positive, whereas the balloon is gaining electrons, making it negative. Alright, so I wanted to show you this cool FET here. So let me open this up. Here we go. So this is kind of like the balloon in the head situation. So right now, all these objects, the wall, the balloon, and the sweater, all have an equal amount of plus and minuses. They're neutral. So right now, we don't stick on anything. But if I take the balloon and I rub it on this wool sweater, kind of like if you rub it on your head, look what's happening. The balloon is gaining electrons, so it has more negative charge. The sweater lost electrons, so it's more positively charged. And when I release the balloon and the sweater stick to each other. That's the attraction force of electric charges. If I take the balloon and I move it toward the wall, watch what happens. The electrons in the wall are moving away. They're being repelled because the balloon has a negative charge. Remember, like and like, negative and negative, they repel. They don't like each other. But the balloon can stick to the wall because these pluses, they don't move. So the negative and the plus, they attract. Remember, electrons are the only things that move. Pluses do not move. Okay? So then we get to the act of transferring charge. Now we have another law that we have to talk about. The law of conservation of charge. It states that charges cannot be created or destroyed. We've heard this law every time that we do a unit. Something can't be created, they can't be destroyed. This time we're talking about charges. So if an object gives up electrons, another object gains those electrons. They don't just poof out of nowhere. They have to go somewhere. And there are three methods in which charges can be transferred to build up static electricity. These are the three words that you're going to use to fill out that reinforcement charge homework sheet that you also picked up yesterday. Friction, conduction, and induction. Now these words, we've already heard of two of them. We know what friction is. Friction is when two things rub together and it creates heat. So friction happens when the electrons are wiped or rubbed from one object to another. This is what happens when you rub a balloon on your head and transfer charges, or a balloon on your shirt, or when you rub your socks on a carpet and you try to go shock your friend. This is friction. It's when electrons are rubbed from one object to another. So anytime you have to rub an object to transfer charge on there, that's going to be friction. Okay? Conduction we talked about when we talked about heat, and conduction was direct touch. Well, that's what conduction here is. Conduction is when electrons move from one object to another object just by directly touching it. So this is what happens when you reach out and you touch a door handle and you get shocked. That's because the charges are going directly from you to the door handle when you touch it. So this is the transfer by conduction. It's by direct touch. When I bring out the Van de Graaff generator, it has a metal rod that's going to touch the big ball, and it's going to transfer electrons from one end to another to transfer and charge the static electricity. So friction is rubbing, conduction is by directly touching something, and that's when the charges transfer. And then we have this last one that we have not heard this word before. It's called induction. Induction happens when electrons move from one object to another without directly touching. In other words, they jump. So have you ever tried to reach out for a door handle or to try to touch somebody, and before you touch them you get shocked? That's the induction. The charge is you have so much charge on you that they're jumping from your hand to the door handle before you even touch it. A lot of the times this happens in the winter when the charges can act better in the cold. So that's when you reach out to touch somebody and you get shocked before you actually touch them. That's induction. So friction is wiping, conduction is direct touch, and induction is not directly touching. So use those 3 words to fill out your picture homework about transferring static electricity. Now the last thing we need to talk about with static electricity is static discharge. So when static gets built up, it eventually has to go somewhere. And that loss of static electricity, when they finally do go somewhere, is called electric discharge or static discharge. This is where you get the shock. So we all know that static comes with that crackling and the shock, everything. That's what happens when you lose static. So signs of electric discharge is you could have a crackling noise, you could have a shock, like when you get shocked from your door handle or the friend, and you should have a flash of light. Lightning is a perfect example of electric discharge. It's a really big loss of static electricity from the electrons in the cloud to the protons down on Earth. This also happens if during the winter, if you have like a wool blanket or a fuzzy blanket, turn off the lights and then crackle it around. You'll hear the crackle, but you'll also see a lot of flashes of lights. It's really cool. So those are all signs that you've had electric discharge: crackling noise, a shock, and then a flash of light like lightning. So hopefully go through the notes, make sure you have filled out all the blanks, and then you have the homework that you can fill out with the 3 words on static transfer and electric discharge. And write down any questions, and we can go over this tomorrow before we start our static electricity labs. Have a fun snow day.